Good morning, guys, or good afternoon, or whenever you're watching this. This should be the lesson for April the 2nd. Of course, I'm posting it on March 31st, so you might be watching it early, but that's, hey, good for you. That's great. But if you watched April 1st, we did 8.1 and 8.2. I told you to do some homework doing the odds for homework. And I happened to glance over y'all's homework for 8.2 and found one that's really similar to your quiz. Not real sure why I did it yesterday, but you know, probably it's just because I am a YouTube newbie and I don't know what I'm doing. So I'm going to go over one of those problems you had from 8.2, and that's on page 336, number 35. And if we look on page 336, number 35, what you've got there is you have a volume problem. They gave you the volume as being 36 with x to the power of 5 and y cubed. And then they gave you this good-looking cube, or this good-looking rectangle. It's actually a, what's it called? Rectangular pyramid or what? Okay, it's not coming to me what it's called. But anyway, it's got that nice three-dimensional shape of a rectangle. And they've given you the length, the width, and you're supposed to find the height. You have one very similar to that on your quiz. And so that's what I want to go to page 336, number 35, and let's set that up and see if we can figure it out. Now, one thing that they assume that you know is what would be the volume of a three-dimensional rectangle. That word is not coming to me, and I should have looked it up, guys, but oh well, you know how it goes. So they assume you know what the formula is for the volume of that. And that would be length times width times height. What you know is you know the volume. They gave that to you. They gave you the length. They gave you the width in your book. And what we're going to do is we're going to smush everything in there that we know. And then we're going to solve this algebraically to figure out the height. Now, this is a literal this is a literal expression or a literal equation, which means you're not going to just come out with this answer that's like 2 or 3 or something like that. You're going to come out with something that's it has to have some letters in it. So don't worry, you know, this is one of those answers that if you see something like this especially on a standardized test, and you've got all these letters in it, you know, sometimes they're fooling you. They'll just give you this answer that might just be 4 or something. And that one is you're going to have to have some letters with it. So let's look at what we got. We're going to take this. I'm going to erase this. Let's erase everything that we're going to put everything we know from right there. So you should be looking at number 35, because I cannot draw one of these rectangles. So let's look at this. We know what our volume is. It's listed to me right under the rectangle. So I'm going to write down the volume. So the volume is going to be 36. And then let's see, we've got x to the 5th power and y cubed. I know what my length is. My length, and I'm going to put that in parentheses just so we can separate it. My length is going to be 3x cubed times y. And then I know what my width is. My width is given to me right there on page 336. I'm going to have to do this. Sorry, running out of board space. And so my width is going to be 2x squared. 2x squared. Nah, let's take that back. Y'all probably noticed where my problem was. Right there, 2xy squared. What do I not know? Look, we got volume. We have the length. We have the width. We do not know what height is. So height, I'm going to leave as h. And then we're going to solve this algebraically. right? Some of this stuff I'm not going to be able to figure out, but that's perfectly fine. So what am I going to do first? First, I'm going to multiply these two little expressions right here. So I'm going to keep volume and just bring it down. Then I'm going to multiply the 3 to the 2. That's going to be 6. That's not real hard multiplication, is it? No, you can do that. And then we're going to multiply the x to x cubed to the x. Remember that we have the power of 3. This x has a little power of 1. And we're going to add those powers together. So that's going to become x to the 4th power. Then I have y times y squared. That y has a little exponent of 1, so I'm going to add that to my y squared, or the exponent of 2, and that's going to become y cubed. What do I still have hanging out, though, that I can't do anything with? That's h. That's h. I can't do anything with it. Right here, guys, what I do lots of times, and this is what we've done in class before, is if you've got this unknown, we could easily just flop it. We normally try to keep our unknown variables over here. That's what I'm going to do in this move right here, is I'm going to put h on this side, and then think what I would do. I'm going to consider this all one big expression. I'm going to divide. I'm going to take everything from my unknown, which is all of this, and I'm going to divide it, use this as my divisor into this, right? It would be really similar to what we've done in the past. Like if we had something that said like 4x equals 8, and then I divided both sides by the 4, and I ended up with a 2. Remember doing that? Well, we're doing this. It's just now we've got, instead of numbers, we have some letters and we have some exponents. So I'm going to write down everything I had down for volume. 36, x to the 5th, y cubed. And then I'm going to divide that by what expression I had left with h, which was the 6, x to the 4th power, and y cubed. So now what we're going to do is we're going to look at this, and we're going to use all the techniques we used in yesterday, 8.2, with trying to solve quotients. When I look on there, it looks like a D, but that's H for height. So let's look. I'm going to divide my numbers. 36 divided by 6, that's an easy one. Shouldn't get your calculator out for that one. It's just going to be 6. Remember what I did with exponents? If I am dividing, then I'm going to be subtracting my exponents. Up here, when we were multiplying, we were adding our exponents. And the way you can think about it is just like how they're kind of set up. I'm kind of setting it up to where I'm subtracting the 4 from the 5, or something like that. So this one I'm going to get into a little bit differently. So if you've got the, or there was another way that we could look at it like that. This once again is just review for you guys. Is if I had 5 x's and then I had 4 x's, because that's me writing everything out, then technically that one's canceling out, that's canceling out, that's canceling out, that's canceling out, and then all I have left is an x. Or I could subtract that, subtract 4 from the 5, and I've got just 1 x. Now look what happens with the y. You could kind of say to yourself, you're not subtracting and really getting a 0 so much as you're dividing the y cubed by the y cubed, and it's just becoming a 1. It's just, it's not a 0 per se. Kind of look what happens. If I had 3 y's, and then I divided that by 3 more y's, all of those would cancel out, and all I would be left with is a 1. This is becoming really light, so I'm going to leave that. So look what my answer is. I end up with my height being 6x. So that's the answer to number 35. You may have looked that up in the back of your book thinking, where's that coming from? And you have something that is super similar to that on your quiz. So, and that's the quiz that I gave you on April 1st. So just make sure you're looking at that. Your next quiz, the quiz you're going to have on today's lesson and Friday's lesson, that's April 2nd and April 3rd, I'm going to give to you on Monday, April the 6th, right? April 6th. So now we're going to go into today's lesson. Hopefully it won't take as long as yesterday, but normally it does. That's one reason why I decided to do YouTube instead of Facebook. Not that my goal is to be a YouTuber, but you know, weird things happen. Let's move on to 8.3. And 8.3 begins on page 338. I'm going to slide everything over because I attempted to write some stuff down prior to the video. Not sure how that's going to work. But I'm going to scoot you over to where I attempted to write things down. Because apparently your book decided, you know what? Don't know what to do with scientific notation, but I know this cool crowd likes to text, so we're going to use some texting notations. I have never seen this abbreviation in my life. JK I've seen, LOL, all the other ones they gave me in my book. Actually, ASAP, I've seen that one. This one, had never seen before, and they put it in my book as basically a lesson opener. Ooh, that's going to bother me because I can see just enough of it. There. This actually stands for you've got to be kidding. You've got to be kidding. That's what that stands for? That's just crazy. So, scientific notation. I know that you had this as a lesson in 7th grade and 8th grade because I've taught those maths. I'm not real sure about 5th and 6th grade. You may have had it there too. I do know that as freshmen taking Algebra 1, you've probably already had this in your physical science course as well. So this isn't going to be brand new to you. We're not doing anything incredibly different at all. So let's just take a second and just give praises that we're not having to do anything different. And speaking of praises, we should make sure we give praise to the Lord. So let's take a few minutes after getting through all of that, and we'll go to the Lord in prayer, and then we'll start scientific notation. So Heavenly Father, thank you once again for just bringing us back together. We love you, and we just welcome you, and just help us to understand what we're doing. And thank you for giving us mainly a review lesson today. And please just be with all those who are hurt and sick and who just need you so much, either emotionally or physically. We love you in Jesus' name, amen. All right, guys, so scientific notation. Of course, some people always say when you get scientific notation is why? Why do we have to do all these weird numbers with exponents and units of 10 and all these type things? Well, no, so many years ago, I had to work on my master's degree, and it was the one time I took a lot of coursework where you had to read lots and lots and lots of research and scientific research where it's involving a lot of statistics and a lot of mathematics and all these type things. And when you read research material, and I'm not just talking about what you find in a scientific journal where they're just kind of trying to bring it down to a person's, anybody can read it, like in the newspaper. But when one researcher is trying to write stuff to another researcher, they very much want to know those numbers so they can make sure they have statistical significance or something like that. That's really important. And that's when, if you started giving these humongous numbers or some of these really, really long decimals, that you would just lose people. Because let me tell you, they gave it to me in scientific notation when I was trying to read it, and I was practically lost too. So this is just an easy way for a scientist to take a really, really big number or to take a really, really small number and write it into a very succinct form that everyone's going to understand. And it's important for you to know, probably for the immediate future for standardized testing or this quiz coming up. But if you go into any type of scientific field in your future, which I hope many of you do, then scientific notation is something that will follow you and that you need to learn and be able to convert one way or the other. So if you want to turn to page 339, I'm just going to write out a scientific notation number, and then we're going to talk about what it looks like. So, for example, I have one right here that they've got in your book, and it's basically picked up the bad pen again. So I have 4.2 times 10 to the 6th power. And let's first of all just talk about the pieces of this number. So in math, most of the time, especially for your all's level of math, we call this 3 basic parts. We call that the coefficient, and we call this the base, and you call that, of course, you probably remember that, we call the 6 is the exponent, because that's just what makes sense, is the coefficient's what's being multiplied to it, the base is the 10, and the 6 is the exponent. In science, or even some math classes, just so you might understand what's happening, in scientific notation, that coefficient is sometimes called the mantissa. And you may have gotten this in physical science or chemistry, but just in case, this isn't something you're going to be tested or quizzed over, unless it's like some weird standardized testing maybe that you're taking. But the mantissa is what the coefficient of scientific notation is called. So let's get into that. So technically, what is this scientific notation? Well, what you might remember from the past is whether it's a really big number or whether it's a really small number, then my coefficient or my mantissa, if we want to be technical, has to be between 1 and 10. It can't be under 1, it can't be a decimal, and it can't be over 10, because that's just how it works. Because basically, this number with the decimal and that exponent is telling me I'm using the base 10 number group, which is what all of our numbers are, what our number system is based on. And I'm going to move my decimal accordingly. So if I have a decimal right there, this is telling me, since it's a positive exponent, that this is a big number. And so I need to move my decimal to my right, with my back to you, or to your left, to the left. So we're going to move this way and make this number bigger. So here we go. We have 1, 2, 3, 4, 5, 6. So suddenly that 4.2 becomes not just a little number, but a big number. This would be like a millionaire coming up to you and say, I've got 4.2 to give you. And what they mean is 4.2 million, not $4.20. So just some little side note. On the express side of that, you might see a number, and I'm still just looking at your examples. Your example is on page 339 of your algebra book. And if you look at your example, they also gave you a teensy-weensy number. This is one of those numbers, you start plugging it in and you don't have a scientific calculator. You got one of those little bitty cheap ones. It would probably start saying, what? And run out of stuff. And okay, and I'll put the little 0 in front of it. I normally don't just because I'm lazy. So we want to make this into scientific notation. So let's think about it. For my base, I'm going to take the actual numbers, not the zeros. I'm going to take the actual number and I'm going to make it between what two numbers? 1 and 10. I want that number to be between 1 and 10. 1, 10. So I'm going to make that 6.7. And then that's going to be my coefficient or my mantissa. And then I'm going to multiply that to a power of 10. But this time, since this is going to be a little number or a baby number, my exponent rather is going to be negative. So if you see a negative scientific notation number, it's going ding, 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 ding. That number's smaller. If you see a positive one, it's going ding, 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 ding. That number's bigger. So let's look at how many places did I have to move my decimal, and we already know it's going to be negative, to get it to 6.7. 1, 2, 3, 4, 5. So that's going to be 6.7 multiplied to the power of 10, negative 5. All right. So they have given you multiple examples in your book of how to do these things, back and forth, back and forth. We've also, you've probably done this in science. I know you've done it in 7th and 8th grade, so I don't want to kill you over going over every single example. Plus, you've probably got other stuff to do. So let's move on to the next page. If you look over on the next page, they've given you a nifty, this is page 340, they gave you a nifty little table to where you can start seeing some of the things that's used in the metric system. And you may have gotten this in physical science, you'll definitely get some of it in chemistry, is that if you're talking about terabytes, that's basically the value of a trillion, so that's 10 to the 12th power. Gigabytes are billions, so that's 10 to the 9th power. So this video is like several gigabytes. Megabytes is 10 to the 6th power, that's referring to millions. We have kilos, so kilos are thousands, so that's 10 cubed. Then we look at the little ones. The little ones start going negative, just so you can kind of get it in your mind. You have milli, which is 10 negative cubed, or 10 to the power of negative 3. If we look at micros, that's a millionth. That's hard to say. That's 10 to the negative 6th power. Then we have nanos, which is a billionth. And that is where our technology is kind of just getting really interesting when you think of nanos and nanotechnology and what we can do if it's really small. Wouldn't it be cool if it's like, hey, you're sick, and instead of taking some type of weird drug, they give you a little nanobot that goes in there and fixes you? That would be cool. So that nanobot is a billionth. It's 10 to the negative 9th power. Now let's move on to your homework. Once again, I recommend you do some odds from each little section or each little exercise in your homework. Now, that doesn't mean I want you to turn it back into me, because I can tell if you've done your homework or not just by how well you're doing on your quizzes or how much understanding you've got. So, I'm assuming that most of you all can write one way or the other, but we can do one just to practice. So let's do 1 and let's do 3 just to make sure you know what you're doing. Then we're going to move on down to exercise B, which is where lots of your quiz looks like. And then we're also going to do a word problem that kind of looks similar to what's on a quiz or a test coming up. So I'm going to do number 1. Let me get a good marker because that blue marker stinks. Not literally, it's not working well. So, number 1 is, this one's a good marker. It must be new. 390 million. Yeah, make that every day, right? All right, so what do I want to do? I want to make my number, my base, right? My coefficient. My coefficient, I want to make it between 2 numbers. Do you remember what those numbers were? 1 and 10. Don't make it some weird number. In scientific notation, if you made it 5 or something that's not even here, it's just like when you fool with the metric system. If you're trying to convert something from kilograms to grams and you end up with a different number, that's a clue you're wrong. Same thing with scientific notation. I need to look at these two numbers. How can I make that between 1 and 10? I can't use 39 over 10. I can't, so I'm going to put a decimal. I'm going to make that 3.9. And then when I go over here and I start thinking about my exponent, I'm going to think, all right, this is a really big number. My exponent needs to be positive, and that's telling me how many times I had to move in order to get this 390 million into 3.9. So let's say your decimal's right there, and let's just count how many times you moved. 1, 2, 3, 4, 5, 6, 7, 8. Checking the book, and that is correct. So I'm going to say, yeah, I've changed 390 million to 3.9 times 10 to the power of 8. And that's just easier for scientists. Let's look at one where we take a little number and we're going to make it into scientific notation, and that's number 3. So if you look at number 3, it's basically 0.00004 zeros. Seems like we did one that was really similar to this, but maybe not. So we have basically 0.4 zeros and 5 2. I want the 5 and 2 to become between which two numbers? 1 and 10. 1 and 10. So I'm going to make not 52, but 5.2 as my coefficient. Then I'm going to count how many times. First of all, this is a little number, so I'm putting down my 10, but that little number tells me what kind of exponent do I need. I need a negative exponent. Negative. Then I'm going to simply count and see how many times did it take me to get to that point, to make it 5.2. So 1, 2, 3, 4, 5. It took me 5 places moving that in order to get it to make it 5.2. So I'm going to make it 5.2 times 10 to the negative 5th power. That's how you do most of those up at the top. Now, under the next expression is where you take scientific notation and then you change it back. I think you all can do that. If you have a problem with that, if you'll leave me a comment, since now I'm YouTubing, if you can leave me a comment below, or if you can leave me a message in Facebook if you're watching off of Facebook, I will try to answer that question for you. Of course, your parents are more than welcome to text me, or that just reminded me I got some weird texts as well. So they're more than welcome to do that. Now what I want to move us to is to exercise B, because this is where the challenge takes place. And it shouldn't, but sometimes it's just like, what am I doing? So we're doing odds. So let's look at that first column. And hopefully I won't mess up today, but it is Mrs. Lamb, so who knows? So let's look at, do we want to divide? Do we want to multiply? What are we going to do, right? So I'm actually going to look on your quiz and see what they've got. So on your quiz with scientific notation, you are going to multiply a scientific expression, and then you're also going to add a scientific expression. So we're just going to pick out 2 of those and just see how you do. And just to make it kind of interesting, actually none of them are interesting. Let's just do 13, because it's really lucky. So let's do number 13. 13 is 2 times the power of, 10 squared. Sorry, did not look at it. And then we've also got 3 times 10 to the power of 5. And all you're going to do, moving that down, All you're going to do here is we're going to multiply our two numbers. And our two numbers are going to be 6, right? Multiplying 2 to 3, that's 6. I'm not multiplying the tens, okay? I'm not multiplying the tens. What I'm multiplying, or what I'm not even multiplying, what I'm putting together, since my bases are the same, I'm going to add those two exponents. I'm going to add the exponents. So that becomes 6 times 10 to the 7th power. Now, I'm trying to look on, yeah, everything there looks kind of good, but let's just say, I'm going to completely change this and see what this looks like. Let's say something happened, and instead of multiplying 2 times 3, where I ended up with, let's take this away, where I ended up with a number that was actually in between those 1 and 10, what would happen? I'm going to keep everything the same, except let's just make the 2 a 4. So now, what do I have? I have 12, and then I need to add my exponents, and I have 10 to the 7th power. First of all, my number is no longer in scientific notation because my coefficient is now what? Now my coefficient is, it's no longer between 1 and 10. But that's easy, breezy. There's not a whole lot. I don't really have to do a whole lot about it, except I need to adjust this exponent. So I'm going to adjust this exponent by not making this 12, but by making this 1.2. And since what ended up happening is I had to basically move that exponent over to over here, which means I'm adding another space where that has to jump. That's what's going to change my exponent. So rather than, and so don't think, oh, I'm making it smaller, I have to subtract. It's like, no, you've made it smaller. That's telling you that that power of 10 has to become higher in order to adjust for your number. So it's going to now become 1.2 to the 8th power, because it's saying rather than having to go 7 places, you're going to now have to go 8 places in order to get what the actual number is going to be. Now the one I want you to look at, because it's very similar to your quiz, is number, where does it be? It is number 19. And 19, they've already set it up for you fairly well. Because, and I'm going to tell you why. You've got 4.3, that's my coefficient, times 10 cubed. And then I'm adding, can you all see this? This is going to run off the page. Let me see if I can do it. All right. The lighting in here is hideous. It's either glaring on my whiteboard or it's doing something else weird. So I have 5.2 times 10 to another 10 cubed. This one's good, and the reason why it's good is because my exponents are the same. So this doesn't have to be the same. This is what has to be the same. And you probably remember that from we did this some last year. But before I can add to make it like terms, and not in scientific notation, my exponents have to be the same. So you might go, as you're going through some of your homework, I know the one on your quiz, your exponents will not be the same. And that means you're going to have to convert this number, even though it's going to look weird and be out of scientific notation, you're going to have to convert it in order to add it together. And then if it's still not in scientific notation, you have to adjust it again. But with this one, we can simply go ahead and do the mathematics, which is adding. So if we have 4.3 and 5.2, making sure I've got everything together, that should end up being 9.5. And then I'm not adding my exponents here. That's just making it like terms. My exponents staying the same. So just remember, you can almost consider this, since this is a coefficient, all that's happening, all that's being adjusted is the coefficient. I'm just adding those. That's it. It's kind of very similar if I had 2x plus another 2x. Nothing's happening to the x. It's just the coefficients of 2 are being added together to make 4x. So I'm going to let you all work on trying to adjust the scientific notation because I'm not finding one really quickly. The next one that I want to work on is a word problem. So if you'll flip over to page 342, and I can tell you right now that my homework that they recommend for you is to do 1 through 39. All right, so if you want to do everything and practice, go ahead. Or if you're bored, you know, there's only so many things on Netflix and YouTube, especially after you turn off me, right? But like I said, you know your own self. So if you don't, know yourself now. And if you need practice, practice a lot more. If you don't, if you got it, then you'll probably be fine. Plus, remember, your quizzes and your tests are going to have to be open book during this sequestering time that we're doing right now. So if you'll flip over to page 342, I cannot remember. I think we're going to do this 31, which is the speed of light. I have noticed in my years of teaching, they love planetary speed of light, especially. It's like the one place where you really use scientific notation because our universe is so vast, and conversely, God is so vast that we have to have, our little puny simple minds have to come up with scientific notation to understand those things. So you've got the speed of light's approximately 30 million meters per second. Earth is 1.5 times 10 to the 8th kilometers from the sun. How many seconds does it take light from the sun to reach Earth? So let's talk about what's happening with this problem. So we basically have 1.5, let me write that down. The Earth's distance is 1.5 times 10 to the 8th kilometers from the sun. I'll just go ahead and put that down as kilometers. And what it's telling us is that the speed of light is approximately 300 million meters per second. That's how fast it goes. So technically, what's happening there is we are kind of adjusting. We're going to have to first of all adjust some of our exponents in order to work through this. All right, you can tell that I've really not kind of worked through this all that much. So let's look at what we're doing. If we have, why is this not coming to me? Okay, all right, I think I've see what is going on. So we have that, and we are trying, so if the Earth is that many kilometers, not noticing, not figuring out how this is working right off. You know how sometimes that happens in class. Oh, now I think I've got it. Because we're going per second. Yeah, Earth is second from the sun. How many seconds does it take to reach the sun? Huh. Oh, yeah. That's what it is. We're adjusting this right here. So we've got kilometers. Our problem is asking us how many millions of meters it's traveling. So we're going to have to adjust kilometers to meters. That's the first thing they're doing before you can fool with this problem. So think about conversions in the metric system. Like we use that, what's it called, that mnemonic device, like King Henry died unexpectedly drinking chocolate milk in order to convert kilometers over to the unit or unexpectedly, which would be our meters, which means I'm having to convert, I'm going from kilometers to let's see, kilometers, hectometers, unexpectedly, and decameters over to units, which means we're going to have to increase this exponent not to, in order to make it meters. I'm going to have to increase this exponent to 11. And now I'm going to say that's meters. That's what they're adjusting, and that's what totally confused me at first, but that's okay. So now that we've got that adjusted, let's take 300 million and let's make it into a scientific notation. So we have this. We have 300 million, and I want to adjust it to be between 1 and 10. So let's think about what we would do there. If I had 300, see, where are we at that? If I can adjust that to 3, think of how many spaces I had to move in order for that to become scientific notation. And we can just look right here. 1, 2, 3, 4, 5, 6, 7, 8. So I took 300 million meters per second, and now I've got 3 times 10 to the 8th power per second. And now we're just going to end up doing a quickie division problem. And then we're going to have to basically adjust it back to scientific notation. So just so you know what we're doing. So we're going to divide. I'm just going to quickly take out that number. We're going to divide the top number by the bottom number. So if I've got 1.5 divided by 3, that's just a pure number, and that's going to end up becoming 0.5. Then my bases are the same. Base is going to stay the same. I'm going to subtract 8 from 11, and that's going to be 0.5 times 10 cubed. But I've got a problem right here. What's my problem? It's the 0.5. Because my coefficient has to be between 2 numbers, 1 and 10. 1 and 10. So, and now what I'm going to have to do is I'm going to have to make this little number into a bigger number, which means that's going to affect this by subtracting it. So we're going to move this number there to make it bigger. That's going to become a 5. And that's effectively me making this little number bigger is going to subtract or bring down that exponent. So that's going to become 5 times 10 squared. And that's my answer. Is basically how many seconds does it take light from the sun to reach the earth? 5 times 10 square seconds is how quickly it is. So God placed us in a nice place in the solar system to where we can get lots of nice light. All right, so that took a while. Sorry, some of my confusion. Sometimes I look over stuff and I think, oh, I can get this. And then when I start looking at it, I get confused. And it magnifies being on YouTube. But hopefully that gives you enough to work on. You'll have another lesson on 8.4. Your next quiz will be on 8.3 and 8.4, which you will not receive until next Monday. So if you have any questions, leave a comment, or your parents have my cell phone number. You can also message me on Facebook if you're using that platform. But have a good day and stay well, and I love you guys. See ya.